Hey Math 1 friends, welcome back to another video. Here we are going to work through a little bit of the 2.3 task. I'll save some for you guys to try on your own, but the main thing that we're working on today is being able to write explicit equations to model linear functions, okay? Writing equations for linear functions. Now, we got finished talking in 2.1 about how linear equations or linear functions are very, very, very related to arithmetic sequences. And so what I want you guys to notice when I start writing out the formula here in this box is that it almost looks identical to what we know about arithmetic sequences. And I should be more specific about equations for arithmetic sequences. So here we go. We start with our f of x. We still, just like with arithmetic sequences, start with the starting output. Here is the big change right here. Instead of adding or subtracting the common difference, we're adding or subtracting the slope times x minus the starting input, okay? Now, we could get super in detail about why this is so much the same, but what I hope you guys can kind of draw the connection to is that slope is the change in y over change in x. And maybe, just maybe, anytime we had an arithmetic sequence, our change in x was 1. Okay, and so all we had to do was we had to count the change in y, and we didn't have to worry about the x side. So the only new thing that we need to worry about here is that instead of just finding the pattern, right, from here to here, here to here, here to here, you have to consider the other side. That's it. Okay, that is the lesson. So, of course, we have to do that now. So I'm going to erase, and let's do some practice problems, okay? So, as you guys can see from our equation, the only new thing, or I shouldn't even say new thing, the only thing we really have to take care of here is the slope. And the reason is because, well, starting output is the same as we've always been. Okay, we know the starting output, and it just so happens that we know the starting input as well. Okay, and so what we have to do before we can get to our equation is we need to calculate the slope. We need to calculate the slope, or the change in y over the change in x. So let's do it. All right, well, we can see to get from 3 to 5, I would add 2. And to get from 0 to 2, I would add 2. So, and remember, again, just a reminder, this side is the change in y, this is the change in x. Okay, so when we go and we calculate our slope as change in y over change in x, we get positive 2 over positive 2. I guess you could keep that, but I hope we're good enough math students that we really like to recognize and see that that 2 over 2 is really just a 1, right? 2 divided by 2 is 1. So now we put it all together because now we have that slope that we need. We would go down, and we could use f of x. I know over here it says y. I don't think we'll stress too much on what input-output you use. I'm going to say f of x equals, well, I need my starting output, which we said was 3. I need to add or subtract my slope. Well, my slope was positive 1, so I'm going to add 1, and I'm going to multiply that slope by x minus the starting input, which is 0, okay? So just like in Unit 1, we could rewrite this as f of x equals 3 plus 1x. It just so happens we could even go further because 1x is just x, and you could even write f of x equals 3 plus x. Now, the one thing I do want to make sure we go back and do, though, I want to make sure you guys see where I'm getting my colors from or my numbers from. So just one quickly, the 1 came from the slope. I'll change to purple now. So the starting output 3, okay, the 3 came from the starting output, excuse me. And then lastly, the starting input, which was the starting x value, or 0, goes right there. Okay? So, this is one where you had to make sure that you calculated both the change in y and the change in x so that you could calculate the slope before going into your equation. Okay? Now, let's see, I'll do one more. Okay, let's do one more, just to be safe. I'm going to skip the middle one, and I hope you might see why. It just so happens that to get from -2 to -1 is adding 1. So I don't know if you noticed this, but this actually kind of goes back. This is kind of a lesson from the first unit, okay? And you know what? Now that I see this, I think I want to go ahead and do this problem. I want to finish this because this has something new in it that we should probably talk about, okay? So I actually just kind of went ahead of myself and I got my change in x. But we need the change in y as well so that we can calculate slope, So I see that here I'm going down by 2. So those are my change in y's. So when I come down so that I can calculate my slope, change in y over change in x, well, I had a -2 over a +1, and that will reduce to -2. Okay, just for highlighting purposes, I want to make sure we know, okay, starting input is -2, my slope is -2, or -2 over 1, of course, would work as well. And then finally in purple, starting output. Okay, so like I have everything I need. I just have to put it into the correct form now. All right, so let's go ahead and let's do that. I'm going to start by saying f of x equals whatever my starting output is. Well, that's a +6, so 6. Here my slope is negative, so I'm going to take away 2, right? It's got to be minus, and then x. And here is why I wanted to continue with this problem, and I thought it was a good one to do. Normally, we take away the starting x value, but the starting x value in this situation is negative. And so from a previous video, maybe you remember, but whenever I see minus a negative, I immediately think of it as a big ol' plus sign, okay? And so now I know that my final equation, I'm going to rewrite it just so it looks a little nicer. But I have f of x equals 6 minus 2 times x plus 2. Okay? Now that could be a little weird, but hopefully it makes sense, right? Like normally the sign of our equation, like in this portion right here I'm talking about, right? X minus 0, or if it was x minus 1, it was because the starting x value was positive. So it almost makes sense that this plus is kind of the opposite of the sign right there, okay? Okay, I'm going to leave the last one for you guys to try on your own, all right? It's a good one to practice with, but again, I'm hoping that you're just seeing this is the same type of thing we were doing in Unit 1, except we must calculate the slope a little differently than just looking for the common difference, okay? Let's keep going. Let's do one where we actually need to either, I guess, use a graph, right? And there's a couple of different options here. One thing we can always do is remember that slope is the change in y over the change in x. And when we have a picture, it's actually really nice to think about this change in y as the rise of the problem, or the rise of the graph, over the run of the graph. So the rise is the up down and the run is always what's happening to the right. Okay? And so if I were going to look and try to do this problem, I'd pick any 2 points. Maybe I'd pick these two. Okay? You could pick others, but for me, with picking those two, I see that, and again, we're always left to right. Always, always, always left to right. I know that I am going down 1 unit, so my rise is -1, while my run, or going over from left to right to the next point, is 2. And so now I know what my slope is, -1/2. And that's m. But Mr. Ravens, like, what point is the starting point? We always talk in this equation as the starting input, the starting output, all that stuff. Guess what, guys? With lines, it doesn't matter where you start, because lines go in both directions forever and ever and ever. So as long as you pick one good point on the line, it can count as the starting point. All right, so just to kind of be a little bit different here, I shouldn't even say that. I'm going to pick this point right here, the one that I kind of started with. All right, and the coordinates of that point were -2, 4. So that's what I'm going to use for my equation. Well, we always start f of x, and we're starting with the starting output. Well, the starting output kind of goes along with what the, let me just go back to my colors for a second so I remember purple. Yeah, starting output goes along with the y value. The starting input goes along with the x value. And our slope comes right from our calculation earlier. Okay, so we have a 4 as our starting output. Our slope was going down, or it was -1/2, excuse me, so -1/2. And then here I would do x. Careful, I'm going to take away, subtract -2. So what am I going to do instead of taking away -2? I'm just going to immediately switch it to a plus. Okay. Now, if you remember, I was saying you could pick any point, right? Let's try something different, just to kind of show you what I mean. What if I picked this point instead? This point is at 4, 1. Well, that's okay. We use that point. So, f of x equals, what is the y value of that point? Oh, it's 1. So 1. The slope doesn't change. But now my x value of 4 will be subtracted from x. Okay, so what I'm trying to get at is there are an infinite amount of possible equations, okay? Depending on which point you pick, infinite amount of possible equations depending on your starting point. And it's kind of just what feels good to you, all right? Now, the one other thing that I want to make sure we cover really quick, because I don't know if I did it in the last video, I'm going to do it again, hopefully pretty quickly, is let's say you don't love this rise over run method. What you can always do, guys, is put the point, or put a couple of points into the table. And so maybe I pick that first point of -2, 4, and the next one is at, let's see, that's 0, 3. Okay? And so I just want to show you, you can get the slope from 4 to 3 is taking away 1. From -2 to 0 is adding 2. So no matter which way you think about slope, whether you use the picture or the graph itself, you still get to the same slope that we were using from the other side. Okay? Okay. Let's see here. Yeah, I think that's what I would like to do on that page. I think you guys should be more, my hint, I'm going to give you a hint for this one, but I want you to try it. I want you to, wrong tool. I want you to make a table. All right, so if you do something like x, y, -4, 8, 10, 3, I want you to see if you can calculate that slope and get it into an equation form from there, okay? So what I do want to make sure we do, because this will lead into our next task, is we're going to be working next time on starting to graph from an equation. And so understanding what a starting point and a slope kind of looks like together will be one thing that'll really, really lead nicely into our next lesson. So, for example, if we did this example over to the left, I would plot the point 1, 5. Well, 1, 5 is right about there. And then what I'm supposed to do is I'm supposed to use my slope, which we know is change in y over change in x, to find other points. All right? Now, I can always go up. Well, actually, you know what? Let's go back a second. I know, just kind of, I've been doing math for a while, right? 1/3, there's two options. 1/3 can either be a +1 over a +3, or it could be a down 1, or a -1, excuse me, over a -3. And so we're going to use these two concepts to get some more points. Let's focus on this one for right now. If I go up 1 and then in a +3 in the x direction, that would be something like this. So I'd go up 1 and then right 2, 3, and I'd get another point. And then maybe I go up 1 over 3 again. So I can get another point. And I could go up 1 over 3 again to get another point. But it is also good to understand that you can kind of think about this oppositely. And so I could also go down 1, back 3 to get more points. Down 1, back 3, etc., etc. And that is just a nice way to show that we can get point after point after point after point after point. And something like that. Sorry guys, my bad. Yeah, there we go. Okay. So what's the idea when you are doing something like this? Well, what did we do? Oop, sorry guys. We need to plot the starting point. And then we use the change in y over change in x to plot more points. Okay? All right. So that's the new stuff. Let's finish up by reviewing distribution and what we mean by this. Okay, distributing goes along with what we did in 2.1, where we were combining like terms. All right, both of those are strategies for simplifying expressions. All right, distributing is another way to simplify expressions. Okay, well, basically, when we see parentheses, that should be our hint that we want to distribute, okay? Distributing is what allows us to eliminate parentheses. All right? And what it is when we see these sets of parentheses with a number out in front, we're actually going to end up multiplying, okay? So let's do a couple of examples and then we'll call it a video. Okay, so basically, the number out in front of the parentheses must be distributed to both, or any, I should say, because it could be other things as well, but needs to be distributed to anything inside the parentheses. So I like to draw these little rainbows. All right, I know that what I'm really doing is I'm doing -4 times 2x, and I'm also doing -4 times -1. Okay? Well, here we need to remember some things. When we have a number times by 2x, well, we're allowed to multiply the coefficients, okay? And so I know that when I do -4 times 2x, I get -8x. Well, what happens when I do -4 times -1? I get a +4. And it's important that we know it's positive because that's going to tell us that this should be an addition. All right, but what have I done? I have now taken something that started with a set of parentheses and it looked just a little bit trickier to something kind of nice and something that's very nice to work with. Now that we're in this form, right, now that I see this, I could combine like terms if I needed to. All right, that would be one thing. And even when we get into further things, this would also kind of maybe sometimes help us when we would need to solve. I think I just said the same word like 5 times. That was weird. Anyway, all right, let's do one more together. I want to do one with a fraction. I'm going to save 2 for you because I want you to try one with a negative, but let's take a look at something like number 3, okay? When I take a look at number 3, I notice that the number that's outside is a fraction. I still am going to draw my parentheses, my rainbows. But what I must do is I must distribute or multiply each thing inside the parentheses by the 1/2. So what I'm really doing here is 1/2 times 8x, and I'm doing 1/2 times -6. Well, 1/2 times 8x, half of 8 is 4, so 4x. And let's see, half of -6, oh, that's just -3, so -3. All right, and there you go. Now you would be ready for anything else that you have to do to help simplify. All right, so that was our lesson on 2.3. The biggest takeaway that I hope you're seeing here is that this is very similar to arithmetic sequences, but we are using slope instead of common difference. Thanks for watching.